Hello, perceptive readers. This is James Lynch. The subject that I want to talk about actually goes into the technical area. And on one hand, I want to share with you up front uh, to just reference my podcast that I told you about trade secrets. And yet at the same time, there are some situations that come up where it's almost like, look, you don't want the bond to burn down, and I do still feel it's it is disheartening at times to see just how far people would still push you from a legitimate wage, and it's still basically because people or the economy is held hostage in the form where it's almost like you got to say something so that the biggest blunders don't destroy the world. Now, with that being said, uh, this is something that normally, it would have been nice to get paid for. Anyway, I looked at a video and I put it on the James Poe Artistry uh, .online website. This podcast that I have right here is just going to go into my buymeacoffee.com/James Poe Artistry. And what the title dealt with was that how the whole world runs off of or runs on a 60-year-old programming language called Cobol. You will remember from one of my exclusive groups discussion probably about a week or so ago. I was talking about different program languages that went back even to the 50s. And I told you even before then, even before COBOL, they had another, language. It was like two more before that, really. I believe at least in the 1900s. And this woman who did a very thorough report, I enjoyed it. I think you enjoyed. So the video is there for you to see, and it's actually in that section of my Who's As Power presentation on the talented Poe Artistry. Okay, it's actually in that section right now. But what I want to tell you about with that language, they was talking about COBOL. And she was explaining how that was the language that actually went from the machine's language that was just, 0 1 0 0 1, on and off, on and off. And sometimes, people would have made jokes over times about, man, you just had to be a true geek to be able to program anything, a computer or otherwise, just using on and off switches, you see, like that. And yet, that's how those persons were back then. So you had some geeks that were making tremendous amounts of money, because she even went into how much one program for one computer could still cost over $800,000 or $600,000, etc. And I was looking at some flat screen monitors and TVs and stuff just the other day where I was at. And the thought went through my mind is, I remember when those TVs were first created, some years ago, they were ranging like $5,000 and $10,000, $20,000. Yeah, back in the day. And now look, you can buy one for less than $500, depending on what. But the whole point that I want to mention, the type of technology that's even in one of those flat screen monitors that you have on your desk, your computer, your TV. Did you know back in the day that would have taken up a whole room, if not a whole site? You see, that's just how much they have been able to simplify, scale down technology and make it more efficient. And so those TVs that we have today, if they would have had one way back then, no one would have been able to afford it, except in this case, as she put in her report, the Department of Defense. And that's one of the things she brought on in the report that even way back then. I talked about this before, how it really was the Department of Defense or the military that had the internet before anybody else, really. Okay. Yet, in this case, and I am elaborating more on even her fine report that she gave, is that she was talking how they wanted to be able to connect all the systems. You see what I'm saying? From Department of Defense to healthcare to even like the economy and the banking systems. Okay, which was accomplished. And it was accomplished through this programming language called Cobol. Okay, now what the language still allows them to do is, remember, it's all about ones and zeros on and off. The timing, see, the timing has to be perfect to be able to make those transitions, see, transactions. And so it boils down to communication. And let me tell you, that would be somewhere, it would have to be installed, you see, on all the systems that would be communicating in that way. And what she was saying in her report is that, no one knows that, it's an eye-catching headline or a title. But what she was basically saying is that nobody knows that language anymore. And, I talked a little bit about that last week about, people in the newer languages, etc. Now, she is one of the ones who has still taken the time to really, learn the language and things of that nature. But the problem is, as she was saying, is that, one, there's a lack of knowledge about, the language that the world is running on. And then she was saying, two, it would just be still even too expensive to make a changeover or what have you. For the banks today, for many of the banks. And so the banks just said, no, it's not worth the risk. And yet time goes on and on and on and on, where, more and more people may be like, So you might have people who can program COBOL that they'll be making it like $1 million a pop. You see what I'm saying? To really fix this or fix that, which, that's a different subject altogether. But this is what I want to talk about. Because on one hand, when you listen to that report, it can almost like still put the fear of God in you from the way that it was. Remember, the Y2K? Remember that situation, the Y2K problem, where they felt like on midnight, New Year's Eve or whatever, when the year changed from 1999 to 2000, that all the computers and stuff like that was going to crash and go down, etc., etc., because they were saying, listen to this, the architecture, see, of the computers even back then, some of the ones that were made with older processors, it was another component in there, but it all dealt with like the type of clocks that just turn, they weren't digital clocks. They were just a regular turning over and things of that nature. And so they were saying they didn't know how things would react. In other words, they would have now people who were, up in age, but once that turn over, they might put them at a different age. So instead of them already being, in their upper 80s or 90s even, they might be now viewed on their birth certificates, if they were to print them out again, as if they were just born. That's just an expression. Same thing with accounts. But see, I still wanted to give you that background, because there was a lot of fear that the architecture, which was archaic, so to speak, would not really match with the type of new technology that was already coming out. And they felt there was going to be a major conflict. And you can still see, for the most part, from the programs and software that during that time was still receiving patches, you see, different patches so that things were supposed to run smoothly. For the most part, it worked. There was no major crisis that, I really know of. I heard of some hiccups here and there, but nothing like the way that they were putting the fear of a Prince song, 1999. But still, what I want to talk about is one of the ways that can still be solved, about the Cobol dilemma that she was talking about, how the world is running on a programming language that no one knows. I keep telling you what a catchy headline. I'm telling you, is this, it's not as, it's not as expensive or as risky as it may sound. And that's from my view. Since we have time, since persons are willing to still run off that same software, forever for all they care, or what have you, then you still would have time to implement what I shared would work. You see, in one way. The first thing, because I talked about automation, I talked about AI, how I'm just still big on human writing. You see what I'm saying? And letters and stuff like that you don't mess with it. But the first way to solve that problem would still be the same way that highly intelligent woman was able to still learn COBOL. You see what I'm saying? At the rate that she was able to fool around or play around with it, to use that expression, then the AI is able to do it as well at a faster speed, much faster speed. So, one, the AI can learn that language in less than a year. Now, even faster than that, I'm just being conservative, aren't I? But the whole point is, and for the bank to mitigate, you see, the risk, the scaredness of saying, look, we can't put all our eggs in one basket, what have you. This is where I get into about the time. And see, and the thing about it is, she mentioned something about the archaic, even architecture or resources or what have you, the different type of computers that they still had back then or what have you, the physical differences. Now, there are some companies right now in the day that have taken a leap. Apple is one of them. From even the type of computers that, that they were making, it's like they said, now we're going to a totally different architecture and stuff like that. And what that has caused, and I've noticed, there's a lot of programmers today that rather even make things backward compatible with older Apple systems and stuff, they just said, forget it. We just going with the new software. See, so, that does cause a serious shock to the system. Even Google has done that with some of Apple's older computers and stuff. It's almost like, we're not updating or fixing this or what have you. Well, the reason why they end up doing it is because of the major physical hardware changes. And seeing that's what the bank is worried about. So it's like, why go to a new language and we still got these, all this hardware, that is just not going to work with, People used to be concerned even way back then, when they used to have what they call, I think, 8-bit PCI buses, 16-bit, 32, and then 64. And to continue to write, software and backward compatible, it was wise of them to do way back then. But now, look, here we are, 100 years later, I'm making a joke on that. It's like now, for the most part, I don't think nobody is writing 32-bit software anymore, unless, once again, they're just learning and they're using older architecture, older computers to actually, you see, uh, uh, to learn to practice on. Even Linux, you see things of that nature, which since it's open source, it may be always be some room for 32-bit programming, just because um, Linux is very generous and freely, encouraging in that way. But see, that's where you start getting into security areas, which that'll be for another time. I'll talk about that. But see, this is, like I said, what banks can do to make it least not as costly. You literally will start with just one controlled environment, just one. Okay. And I'm not telling you nothing that I know somebody hasn't already thought about. But in that controlled environment, yeah, you still have the new architecture. You see what I'm saying? You still have the new architecture, one. Then you still have, like a redundant or a clone, if you will, of the old architecture, another computer or what have you, side by side. You see what I'm saying? And you have your new software that is learning, that is communicating, AI, if you will, with the software. Because remember, when I said this is a controlled environment, so the whole point is all you're doing is really just cloning the information. You're just copying the information over, you see, the transactions and things of that nature, so you can see where the hiccups are happening, even in the code. You see what I'm saying? So you can have the new programming language, etc. You see, with these transactions, that monitoring, and it's like they're going real time. You see, still separate. It's like a separate network. You see, separate internet, firewall, DMC, if you will. It really stays separate. But you just have a way that, you're connecting the information to. See, it's the same way that even our domain systems are set up today, even on the internet. When you buy a computer name or a company name or a website or what have you, yeah, uh, you just put something in the web browser. You see, like jamespoetry.online, and guess what? You get there with no problem, because it talks to the DNC's DNS servers and everything. Excuse me, DNS servers, and it's like boom, it's instant. But the point is, you still have some main servers that are heavily guarded, you see, around the world. Major protection. I mean, they more heavily guarded than Fort Knox. I mean, where it's on the same level, or what have you, from what I understand. And who knows, they may be in there with Fort Knox. No, but the whole point is, they don't stay connected to the internet, but they always really, they have, I wouldn't be surprised if they're out in space now. Oh, I digress. I'm getting ready to, go on another world. But the whole point is to keep from having all that DNS poisoning from what hackers and stuff be trying to do all the time. They still have a solid copy of everything that's going on. It's protected. So that's the same thing that I'm talking about with banks. If they ever really want to go to the new software of the communications, and which I know would involve, like was mentioned earlier, the Department of Defense, you see that all three of them would be connected in that way. It can still be done. You see, it can still be done. And again, I want to emphasize, I'm pretty sure somebody already has thought of this. Yet this is still what I want to emphasize about the architecture, the physical layout of such things. See, because the bank may feel that, it would still be too expensive to overhaul, all these systems and stuff like that, which I don't really think would be no more out of the budget if it's just done. Remember I said you got forever, in the sense of whatever, that You would just work your way out to other different control sites at a time. And you would just set up, those systems each way, each way, each way. And then when you finally then went through all the thousands of banks or what have you eventually, then when the time comes or what have you, and you already had years, you see that's me really just being careful. But I know some persons, they like to jump fast in there. But I'm just saying, you already had years and no hiccups whatsoever. None whatsoever. When you got all those kinks work out, I mean, no beta, no nothing. No, you are really just keeping it together. Okay, keeping it together. Then when it times, to really switch to all the new architecture stuff like that, it'll be smooth sailing because already you've been building yourselves in a more fine foundational way. So anyway, there's more to it, but just by that information, all those smart programmers and hardware computers, builders and things of that nature, they got to know how to really do the rest. And so anyway, take care of Perceptive Readers and have a good day.